Soon another piece of cutting-edge European technology will be delivered to the International Space Station. ERA, short for European Robotic Arm, will be launched on a Proton rocket from the Baikonur Cosmodrome together with the Russian Multipurpose Laboratory Module, Nauka. This brand new Russian module will be ERA's home base for the next 10 years. The 11-metre-long ERA arm can lift up to 8 tons and be operated with an accuracy of an astonishing 5 millimetres. One of the most impressive features of the robotic arm is that it can move hand over hand over the Russian module.
The ERA arm is completely symmetrical. This means it has a hand or an end effector at both sides, and that each side can serve as the tip as well as the shoulder. So it means that if you have multiple base points on the Russian segment, you can go from one base point to the other, then release your tip or your shoulder, which becomes tip, and then manipulate a payload. So in that sense, it has freedom of motion on the space station.
With this freedom of motion and well-chosen location, ERA will be able to service the Russian segment of the space station, which is not in reach of the other 2 robotic arms already installed. ERA is fully programmable and has several modes of automation. This means each mission can be prepared on the ground and then uploaded into the arm's computer, after which the astronauts on board can run and authorize each step of the mission. Theoretically, ERA could even work autonomously and run the mission all by itself. It also offers the possibility for astronauts on board to piece together a new mission on the fly if necessary. The arm will have several important applications to alleviate the work of the astronauts on the International Space Station. As crew time is precious and the safety of astronauts is paramount, the arm can be used for tasks which are described as the 3 Ds: dull, dangerous and difficult.
The robotic arm can be used for example, take payloads out of an airlock autonomously without the risk of an extravehicular activity, for example, and put equipment on the outside. It can be used for inspection. It can be used for putting big new modules, for example, and putting it on the space station, move big things around. And also it can be used to help the cosmonauts when they're doing a spacewalk, to move cosmonauts around or big payloads while the astronauts and cosmonauts have their hands free to work on the outside. So it can be used in several ways.
ERA has been specially designed for collaboration between man and machine. The astronauts can even operate the arm from outside the space station during spacewalks, using a remote control which has been optimized to be used by astronauts in bulky spacesuits. French ESA astronaut Thomas Pesquet, who is currently at the space station, will be involved in ERA's commissioning when the arm first arrives at the space station. Later, Matthias Maurer and Samantha Cristoforetti will take part in the installation and operation of ERA through various spacewalks. One of ERA's first tasks will be to install the radiator and airlock of the Nauka module, so the laboratory can become operational. And ERA can use this airlock to move payloads from inside the station to outside.
When we operate the ERA on the ISS, we're obviously going to learn a lot about how to use robots in space, how the robots work in space. We'll have feedback to our engineering process if we finally know what is the performance during its use in space. But we'll also learn on what we can best do with robots, what we can best do with people, and learn about the cooperation. And all of that is going to be very, very useful when we would go further into the universe and still have, for sure, robots initially, but maybe at some point in time also people with robots. So we're really looking forward to all what we can learn from the experience on the ISS with ERA.
ERA is another example of cooperation between Europe and Russia, and a tribute to the excellence of European industry. The project was commissioned by ESA and largely funded by the Dutch government, with Airbus Defence and Space Netherlands as its prime contractor. Now the European Robotic Arm will fly to the ISS, and with it a new era dawns for the International Space Station, already one of humankind's greatest achievements. ERA offers a look into the future of space robotics, and the cooperation between human and machine as we further explore our universe.